take a case where you see that f of a exists. We want to see an example where f of a exists, and then limit as x tends to a of f of x this limit exists, but f of a is different from limit of f of x as x tends to the number a. So we're going to find an example of such a function. And so if I give you the function f of x is 4 if x is strictly bigger than 2. It is minus 3 if x is equal to 2, and then it is 6 minus x if x is less than 2. Our goal is to see, first let's compute the limit of f of x as x approaches a. So we need to choose an appropriate a that will do the job for us from here. So our interest here is 2. So let's look at limit of f of x as x tends to 2. You see from here that this function is defined piecewisely. So for all values of the set of real numbers greater than 2, f of x is this constant 4. Therefore, if we're approaching 2 from the right, this limit is 4. If again we approach 2, that means we compute the left-hand limit of the function, as x tends to 2 from the negative side, meaning we're considering all values of x that are smaller than 2. But this function, if x is smaller than 2, what the function will produce is 6 minus x. So as x gets very close to 2, 6 minus x will get close to 4. And that says that the left-hand limit of this function is 4, the right-hand limit of the function is also 4. Therefore, our limit of f at x as x tends to 2 is exactly 4. Alright. What this function does again is that at x equal to 2, the function will produce negative 3. And so we have f of a, which is f of 2, is negative 3. And then we can see that negative 3 is not equal to 4. And so this example is a good example to show that f of a may exist. The limit of f of x as x approaches a can also exist, but the two are not equal. So we learn here again this situation. Please pay attention to this example. When we study continuity, we shall come back to this example to use it to learn one other thing. Alright. All this while we've been talking about limits of f of x as x approaches a fixed number a. The question of interest now is, suppose a is not a fixed number, so it is, say, positive infinity or negative infinity. Can we still compute the limit of such a function? And so this question brings to what the topic we call infinite limits of functions. So we want to learn how we can compute the limit of a given function as x approaches plus infinity or as x approaches negative infinity. Alright, so another thing you should realize is, which I think I discussed in the previous video, is we can have a situation where the limit of a given function f at x as x approaches a fixed number is plus infinity. We can have such a situation. We can also have a situation where the limit of f at x as x approaches a fixed number is negative infinity. Such exists. In fact, without spending much time before I come to this, let me give this example, So I give our f at x to be, say, 3 over x minus 2. Now, we want to see what the limit of f of x is as x approaches 2. You see here that as x goes to 2 from the positive side, so I compute this. Okay. Permit me to use here, and then I come back to this infinite limit. So as x approaches 2 from the positive, that means limit of f of x as x tends to 2 from the positive. That means we are considering all numbers greater than 2. If you consider all numbers greater than 2, x minus 2 will be greater than 0. But as x approaches 2 from that right, this approaches 0 and they are positive, so 3 over x minus 2 will approach positive infinity. And so I can write this as plus infinity. Again, the limit of f at x as x approaches 2 from the negative side. From the negative side, I mean all numbers smaller than 2. And then if you consider a number smaller than 2, x minus that number is negative. And therefore, x minus 2 will approach 0 from the negative direction. And that gives us that 3 over x minus 2 is going to negative infinity. So I can write this. So this is a case where the limit of a function as x approaches a fixed number is positive infinity, and as x approaches a fixed number, the limit is negative infinity. So this is one possibility. Another one is what I'm going to consider here, which is the title again, infinite limits. So I want to take a look at what happens to the limit of f at x as x goes to negative infinity or as x goes to positive infinity.